Hello students, in this video I am starting chapter 7 coordinate geometry. So this is the first video of coordinate geometry. See very carefully. Here I begin. How to locate the position of a point on a plane. So you have already done in class 9th that there is a plane surface where x-axis and y-axis are there. So we require a pair of coordinate axes. The distance of point from the y-axis is called x-coordinate. It is also called abscissa. And the distance of the point from the x-axis is called y-coordinate. It is also called ordinate. So the coordinates of a point on the x-axis are of the form x comma 0. Here value of x is there but value of y is becoming 0. And of a point on y-axis there is a form 0 comma y. Here y value is some value and x value is 0. The coordinates of the origin are 0 and 0 and the form of point in different quadrants are. So what are the quadrants? Let me explain you. If this is y-axis, this one is x-axis, then this is called first quadrant. This is second quadrant and this one is third quadrant. You have already done it in 9th class. This is fourth quadrant. And all the points which exist in these four quadrants are, see, the first quadrant is of the form AB and the second form minus AB. In third both are negative. In fourth B is negative. So here this point, all the points are of the form x comma y. We first write x value, then we write y value. Let's find the distance between two points P and Q. So P and Q are two general points in the coordinate plane and we have to find the distance. So there is a distance formula. In this, I'm going to derive the distance formula for you. See very carefully. Draw PR and QS perpendicular to x-axis and PT perpendicular to QS. So let me draw this for you. This is x-axis, this is y-axis, this is x, y and origin. Now P and Q are 2 points. The line joining these 2 points is this. Now this distance we have to find. So this distance is a distance formula. Let's calculate. Draw perpendicular on x-axis, y-axis and PQ, and these are the points T, S and R. So see very carefully. Then OR is equal to x1. X1 is the distance. OR, see, OR is this one, this distance. And RS, this distance I'm talking about, it is total distance x2 minus the distance x1. So this distance is this. Next is, it is equal to PT because RS is equal to PT. So this distance we have calculated. Next step is, also SQ is equal to Y2 and ST is equal to Y1. See very carefully in the diagram. And QT is equal to this distance I'm talking about. Distance is equal to Y2 minus Y1. Now see the triangle PTQ. If base and perpendicular is clear to us and this is hypotenuse, so we can apply Pythagoras theorem. Let's calculate with the help of Pythagoras theorem. In the triangle PTQ, PQ square is equal to PT square plus TQ square. Now put the values that we have already calculated. X1 minus X2 is the value of PT and Y2 minus Y1 is the value of QT. So let's calculate it. TQ and QT both are same thing. So PQ square is equal to X2 minus X1 whole square and Y2 minus Y1 whole square. Now this square will go that side, it will become square root. So PQ is equal to square root of X2 minus X1 whole square plus Y2 minus Y1 whole square. This is called distance formula. So the distance formula is very much clear to you. We will apply this distance formula in many questions in exercise 7.1. Example number 1. Do the point 2, 3, 2 -2, -3 and 2, 3 form a triangle. So first of all we have to check it is a triangle or not, and if it is a triangle, which type of triangle is this? So let's solve this. Let us apply distance formula to find the distance between PQ, QR and PR, where P, Q, R, these points are given in the question. So this is distance formula, you know, applies this distance formula to find the distance between these three sides. So PQ is equal to this one, and I'm solving it for you. It will be equal to square root of 50, which can be further calculated as 7.07. So this is the distance between P and Q. Next is, again I am applying the same distance formula for you. Distance formula is x2 minus x1 whole square, y2 minus y1 whole square, and whole square under root. I am solving it for you. It will become approximately 7.21. This is second side. Now third side is this. With the help of distance formula, find third side, and it is approximately 1.41. Now because sum of two side is greater than third side in all three possible ways, so it is a triangle. Means these three things are proving that it is a triangle, that sum of two sides is greater than third side. And if we apply Pythagoras theorem, square root of 52 square, square root of 50 square, square root of 2 square. So 2 is cancelled with square root. In all three steps, 2 is cancelled with square root and 2 is cancelled with square root. Then it will become 52 is equal to 50 plus 2, which is a true statement. If it is true statement, it proves that Pythagoras theorem is fit on that. That implies it is a right angle triangle. So in the first step we have proved it is a triangle. In second step we have proved it is a right angle triangle. Since sum of any two sides of the distance is greater than the third side, so it is a triangle. Now if it is a triangle, Pythagoras theorem is also applied on it, so it is a right angle triangle. Let's continue. Now I'm doing example number 2 for you. Show that the point A, B, C, D are vertices of a square. So solution is, to show that ABCD is a square, we need to find distances. Now what are the distances required? We need to find distance of all four sides of the square. Now once all four sides are equal, it may be a square, it may be a rhombus, so we need to find the distance between two diagonals also. The length of the diagonals is also calculated. See, I'm drawing the diagram for you. A, B, C, D, and these are two diagonals. So we need to find AB, BC, CD and DA, and also we will find AC and BD, which are diagonals of the square. Let's see. AB is equal to, with the help of distance formula, AB I have calculated for you. It is under root 34. Now next is BC, which is again with the help of distance formula. I am calculating it for you. It is again square root of 34. Next is CD. I am calculating it for you. This is again square root of 34. And DA, I am again calculating it for you. This is again square root of 34. So for all four sides are equal. So it means either it is a square or a rhombus. But to check it is a rhombus or square, we need to calculate the length of diagonals also. So let's calculate AC and BD also. AC is equal to this. After solving, it is becoming square root of 68. And BD is equal to, again after solving, it will give the value 68, square root of 68. So two diagonals are also equal. That implies it is a square. Since all four sides are equal and diagonals are also equal, therefore ABCD is a square. Let's do one more question. Example number 4. Find the relation between x and y such that the point xy is equidistant from the points 7, 1 and 3, 5. So here one point is given, say x and y, and other 2 points are given, say these 2 points. Now the equidistant point are this distance is equal to this distance. So these two distances are equal. Now there are many such points, see very carefully, on this line whose distance is equal. So we have to find the equation of this line. The whole line is equidistant from these 2 points. So let me solve it for you. See very carefully. Solution. Let P is equidistant from 7 from A and B. Therefore, PA is equal to PB. So by the distance formula, we will find PA and PB both. So PA is equal to, with the help of distance formula, I have written this. PB is equal to, again by the distance formula, we have written this. On solving, on squaring both sides, on squaring, when I'll square this one, square will be cancelled with under root. And here also, if I square this right hand side, the square will be cancelled by under root. So the new value will be, see here, this square roots are cancelled. Now by the ID x minus y whole square, I'm calculating it for you. X square plus 49 minus 14x plus y square minus plus 1 minus 2y. This is equal to x square plus 9 minus 6x, y square plus 25 minus 10y. On solving it, x square is cancelled with x square, y square is cancelled with y square. Now only values which are left, we will take it in the left hand side. So it is equal to minus 14x plus 6x minus 2y plus 10y is equal to, these values will go that side. See how to solve it. Minus 8x plus 8y is equal to 16. Now take 8 common and it will go the denominator of minus 16. It will be x minus y is equal to 2. So x minus y is equal to 2 is the required relation. It was asked in the question, find the relation between x and y. So x minus y is equal to 2 is the relation between x and y. Now, on the basis of this video, you can do exercise 7.1. And for daily practice and for your doubts, you can attend the online class. For online class, you can contact me on my number. So please, if you want to do extra practice and you want to ask the doubts, you can WhatsApp me or you can call me on this number to attend the online class. Thank you.